The first thing I'm going to talk about is wind direction. Wind direction is affected by the pressure gradient, the Coriolis effect, and friction. Through the pressure gradient, wind goes from high to low pressure. The wind molecules that are in the higher gradient feel more pressure and try to go to the lower pressure zones. In situations where you have higher pressure, there will be stronger winds. The closer the isobars, the higher the wind speeds. The more spaced out the isobars are, the lower the wind speeds will be. Although the pressure gradient causes the wind to go from high to low pressure, the Coriolis effect force causes the wind to go parallel with the isobars. This creates winds known as geostrophic winds, which only occur in the upper winds. Friction affects wind near the surface. Near the surface, wind direction is not parallel with the isobars, and the friction causes the wind to slow down. By causing the wind to slow down, it reduces the effects of the Coriolis effect in the lower region. The next thing is the Coriolis effect. The Coriolis effect happens when wind does not cross the isobars at right angles as the pressure gradient would normally direct it to do. The direction is deviated as a result of the Earth's rotation. All pressure systems, regardless of the hemisphere, go from high to low pressure. In the northern hemisphere, the Coriolis effect causes the wind to deflect to the right. This deflection of wind causes a counterclockwise rotation. And in the southern hemisphere, the Coriolis effect causes the wind to deflect to the right. This deflection causes a clockwise rotation. Why and where air rises and descends. In a low pressure system, warm air rises. The air undergoes a process called convergence, which pushes the warm air upwards. In a high pressure zone, cool air descends. In a low pressure system, the converging surface winds and rising air results in cloudy conditions. In a high pressure zone, the diverging surface winds and descending air results in clear skies and better weather. How the general circulation of the Earth affects climate. The Coriolis effect and convergence causes the air to rise and affect the circulation of the Earth's air. Near the equator, the rising air is associated with the pressure zone that is referred to as the equatorial low. This region has ascending, moist, hot air which creates an abundance of precipitation. Because of this being a low pressure zone where winds converge, it is also known as the intertropical convergence zone. In the equatorial low, as the upper level flow reaches 20 degrees to 30 degrees latitude, north or south, it sinks back towards the surface. This creates hot and dry conditions. The center of this zone is known as the subtropical high, and that is where the great deserts of Australia, Arabia, and Africa exist because of the unstable and dry conditions. At the surface, air flows outward from the center of the subtropical high. When this is deflected by the Coriolis effect, it creates trade winds. The remainder of the air travels towards the poles and is deflected, which creates the westerlies.